what a turnout.
It's the free food.
Vice President Chalupa thinks it's the quality of food that brings you here. I think it's food for thought that brings you here. So thank you so much for coming. There's so many of our great faculty are here and also administrators. So I would like to take a few minutes to recognize a few people. First of all, I would like to thank Vice President Chalupa's office for co-hosting this event. And he will be here telling you a few things. He has been a staunch advocate of the Virginia Science Technology Campus, and I'm very grateful to him for standing up for the potentials of this campus. And we'll hear from him, so I don't want to repeat anything that he might be wishing to say. Secondly, I would like to thank Dean Barrett, who's here. As a very special thank to Dean Barrett, who's there, without whose leadership and investment in various fields in the Colonial College of Arts and Sciences, this particular initiative would have never come to fruition. It was her foresight and creativity that allowed people to think along non-traditional lines of how to support research in the university. Later on today, there's a reception honoring her substantial contributions to the university. So I really want for everybody to recognize her as the leader that she is, and let's thank her for what she's done for the university. On the division of IT, Dave Steinour, you can see him here, sitting down. He is the leader who has really contributed to bringing this particular initiative to fruition through the tireless efforts of Brian Enzer. I don't know where Brian is, sitting out there. And in collaboration and partnership with Sean Connolly from the Colonial College of Arts and Sciences. Where's Sean? Or Sean is sitting there. Every time I pronounce his name, I'm expecting 007 for some reason. But thank you, Sean, for making this happen. We've had, as one of the featured research areas at the Virginia Science and Technology, we've had the High Performance Computing Research Lab. And professors and scientists and researchers who work in that lab have been very kind to let a lot of other faculty from the university to use that lab for their runs, for production runs, basically. But that lab was never really designed for that purpose. The main purpose of that lab was to test out, as a computer scientist might, the various configurations for processing, faster processing, most efficient and optimized processing, both learning and hardware and software, how to do it. And so sometimes the use and operation of that facility by people other than the researchers in the computer science department would cause them some problems, because there was problems of timing, problems of dead time, and other things. So some of us thought that it would be very wise to have really a production facility for high performance computing for our top-notch faculty members who do a lot of computational work. And as I said before, Dean Barrett actually is the leader who oversees a lot of these faculty members. And she saw it to the advantage of the university that we would be thinking strategically about investing in high-performance computing. It's an area that we would like to be known for. Just to reassure you that this is something that the university really thinks highly of, the Loudoun County Chamber of Commerce invited President Knapp to come and give a speech, and President Knapp talked to them about the areas that the university wants to invest in. And one of the areas, of course, was the investment in high-performance computing and other interdisciplinary institutes that we will put in place alongside the Computational Biology Institute that's on its way through the leadership of Dr. Crandall, who's here and will be talking to you briefly. So I would like to assure you that there is a strategic thinking that's going on. I'm in the process of coming up with a strategic plan for the campus, and you'll have an opportunity to actually provide feedback for that. One of the main areas that we want to move into is high-performance computing and all the other related fields of science and engineering that touch upon high-performance computing, such as big data, such as computational sciences, as far as they're related to the health science fields and biological and life sciences. So We're still in the initial stages of thinking, but I will share all that with you. But right now, I think it's time to celebrate a very grand occasion for a milestone that's happened on this campus as an event that will be the precursor, I hope, to many other important events that will promote this campus and make it a magnificent campus as opposed to what Shelley Heller talks about, the Mount Vernon campus as a beautiful campus. So we'll call this the magnificent campus. If the name sticks, please keep using it. So with that, I would like to invite Vice President Chalupa to make some remarks.
Thank you for hosting this. You're the host with the most. You're paying for the food, you provided the space.
I am?
Oh, well, yes you are. So you said some wonderful things about Dean Barrett, and let me kind of give you a little bit of background about how this initiative came about. So I chair a group that probably many of you don't know about that has an acronym called EROC, E-R-O-C. It stands for Executive Research Oversight Committee. And we meet roughly once a month, and members of that group are Provost, Lou Katz, Jeff Ackman, and Bette Nolan. And so we deal with issues having to do with anything related to research, and often we invite other people like Dave or Brian to come in and talk to us about various problems. And so one time, Dean Barrett came and she said, I had this proposal for a high-performance computing initiative, and I invited her to present this proposal to EROC, and she did, and it was really a wonderful presentation. Not only did she speak passionately about it, but she also had a beautifully done kind of pamphlet, more than a pamphlet, a little book describing what it would do, and it was going to be a campus-wide thing and so on. And the members of EROC were all very much impressed by that until it came, well, who's going to pay for this? Remember this, Peg? And at that point, people started kind of looking around, and so on. So I found in my 4 years being here that things really move quickly until you start talking about who's going to pay for it. And then it comes to a sudden halt. And so, well, maybe the provost should give some money, maybe somebody else should give some money, maybe we'll get the deans and so on. And when the finances are being worked out, things tend to stall. And so what happened is, instead of waiting for this thing to go on and on, she just basically essentially funded it herself with input from Dave's group. And it was a wonderful example of the way she's led in the 4 years I've been here, where you try to get things done one way, and sometimes they work and sometimes they don't. But if it's important to get it done, you get it done. And in this case, she got it done in a wonderful way. So Peg, I congratulate you and your team. It's great. We wouldn't be here having this free food that Elise put together without this initiative. So I want to give you kind of the research perspective on this, the way I see this, what's going to be here. And this computing facility is absolutely critical to this. So I think it's no secret that the Virginia Science and Technology Campus is a wonderful resource that is mightily underutilized. And so the question is, how do we best exploit what's here? There's some wonderful research here, some great people doing great stuff, but we certainly could handle a lot more. And so the vision is that we're going to have a focus here on big data. And big data is something like MOOCs. You see this all the time. The Wall Street Journal, on I guess a couple of days ago, had a whole section on big data, on business and big data and so on. So we started this out with Keith Crandall's recruitment, and Keith came in computational biology, and it's a campus-wide initiative. His appointment is in biology, but he's recruiting 5 people that have a different way of recruiting people. We're going to get the person first, get the best person we can. They have to have money to come in here from outside, and then we're going to find a department for that person. This is a way of going across campus. And so Keith will in not very long period of time, have that set up. And the next thing we're doing, the search committee is meeting tomorrow, as a matter of fact, is the second component of the big data initiative. We're doing one in genomics / bioinformatics / personalized medicine. It's quite broad. The exact area doesn't matter, but we're going to do the same thing we've done with Keith. We're going to hire a stellar, internationally known director, somebody who's has that oh wow factor. You know, we want the kind of person that when we hire this individual, when we hire him or her, emails will go around the world saying, do you know who GW got? Wow, that's what kind of person we want. And so we will give that person 5 positions. And the search committee, as I said, meets tomorrow in my office. The provost will be there as well. And we want to get this off the ground come, yesterday. And so we're not going to rush this because the critical thing is to get somebody of tremendous strength and also somebody who's collegial. So that person will get 5 positions. And then sometime late fall, we're going to do the 3rd big data initiative, and that's to be decided exactly what it's going to be, but it's going to be more focused on engineering. And Dean Dowling's put together a group, and they have already come up with several preliminary plans. So we'll launch that one perhaps October, November. So here's the vision. 3 directors all working together on overlapping but separate things. The common feature is they need a computer facility, which is what you provided. Each director will appoint 5 faculty, so that's 6 times 3 is 18. Now you can imagine each faculty member would have a minimum, let's say, of 5 graduate students and or postdocs. So now what you have is 80 people, all working on related stuff, but yet separate, working together. And hopefully, if the plans go the way they should, that should more than double, more than triple the funding out here. It should provide us a powerhouse and a signature that will be known all across Northern Virginia, and in fact, well outside this region. So that's the vision. And I've got the money committed. I've got the president on board, the provost is on board, the trustees who know about it on board, and so we're going to do it. And now it's just a matter of getting the right kind of people. So if you know somebody, anybody here, if you know somebody of that kind of quality who'd be interested in coming here, call them up and give them my email. Happy to talk to them. Because people of that quality, as you all know, don't look at ads. They look at what's what opportunities are available. They have to be seduced, so to speak, to come here. So a couple little things. One is a faculty member in a school other than Colonial College came to me and just a little while ago and said how wonderful this was, and this individual said, I can use this, but I wish I had priority. And my answer to that faculty member is, get your dean to put in money. So all of you who are not in Colonial College and on priority, speak to your deans, tell him or her to kick in some bucks into this, then you'll have full priority. You got to pay to play. So that's one thing. The other thing I want to just kind of point out is I looked at this description of this in the website of Colonial College, and this is for you, Dave. So it describes this very nicely. Whoever wrote it did a good job writing it. But what I noticed as I scanned this thing is that each time they refer to IT, every single time in this little thing, they always say the professional IT management. The word IT is never used without professional. And that made me kind of feel like, are there any other types in your outfit? So,
Yes.
well, we don't want those working on this. So, Dave, the floor is yours.
First of all, I'd like to say thank you all for coming out to this Colonial One launch. These are very exciting times for the university and for the IT department in our partnership with the Columbian School, our partnerships that we're building in the medical schools, both of them, School of Public Health and School of Medicine, and across the university. 5 years ago when I started, we were seen as people who sit behind locked doors, do whatever we want with the resources we have, and we don't pay attention to the academic side. And I think through this partnership, we've got a lot more visibility on what we can and can't do when we partner within our division and also across the academic areas to see what we can do. And what we are going to see today is a result of that partnership. And to me, these are very exciting times. We're now part of the research process where 4 years ago we weren't. And we're helping to build what one of the strategies are for the university, which is research. And we feel pretty confident that we can stay engaged in what we are doing. And I believe this is step one to many steps to build out what will become true high-performance computing from a central standpoint that'll service the research areas across the university and across the divisions. So for me, these are really exciting times. We're making good progress. We've had the ability to partnership with the Colonial School. We hope to extend that to others where we can keep building on the momentum that currently exists with high-performance computing as we go forward. I do want to make sure I call out a few people. Sean Connolly especially, great liaison for the faculty, good partner to us, got us started in this, and it's worked very well. Warren Santer, who served as a primary architect. Randy Shore, who was responsible for communication, the website and the Twitter feeds that you're all seeing. Glenn McLaughlin, he was responsible for the design and implementation. Dean Peg Barrett, of course, for the funding, which we couldn't have done anything without her, and we are very grateful for that. Thank you, Peg. Keith Crandall, Tim McCaffrey, and Andre Alexandru, planning and interviews that defined the requirements that led to the design of what we have. Steve Dobbins and Tom Love from Division of IT for the implementation team. Tom Wickberg, who is our new face within the division for this service. Leo Chalupa, Lou Katz, and Steve Lerman, who were executive team support. Rachel Blevins, Andrea Phillip, Dova Wilson, and Kara Wright for the organizing they were the organizing committee for this event. And most importantly, from where I sit, is I can't say enough about Brian Enzer. He was hired 2 years ago, and he's made great inroads into building these relationships with the academic departments, the research community, and because of him and Sean, we're here today to present to you what they came up with. So that shows you good partnerships really do work across the university. It's a matter of just understanding the requirements, knowing what you need, and joining together to try to make it happen. In silos, we're never going to be successful, and this is proof of that. So I encourage you to continue this momentum as we go. Partner with us. We will be happy to partner with you to keep the momentum going and to satisfy the research community with their requirements and their needs. So I look forward to our continued partnerships with the research PIs, the schools, and the research office. And I thank you again for the opportunity to come here and speak to you today, and I hope you enjoy the rest of the program. Thank you very much.
Things have changed a lot since I showed up on the Foggy Bottom campus as a young, naive, 26-year-old assistant professor with a box of these under my arms. Yeah, we got a few giggles, and that's because the rest of you don't know that these are punch cards for the IBM computer, and I had a program encoded on these cards called Wagner 78 that generated phylogenetic trees, evolutionary trees of organisms. And evolutionary trees are just about the most wonderful thing in the world if you're a biologist. They're networks for all of you math geeks, that's what they are. And you can see how they tell you how organisms are related. But more than that, where there's a node along an inner branch there, along an edge, I think the math people would say, you see that this forms a group, and you can map data onto these trees and use them to summarize all the information that we have about life. And you can put names on the little nodes and then use those to take shorthand. And it's wonderful. All of biologists use it. Now, I could say to Ali, I just saw a little warm-blooded animal with mammary glands, 3 different kinds of teeth, a hard palate, warm blood, 4-chambered heart, run across the back of the room. Or I could say, you have a mouse. So these names that go on those nodes are very powerful for summarizing information. But generating these trees is computationally very difficult. And it's what someone in math told me was classified as an NP complete, or as they call it, a hard problem. It means that you can't actually compute exact results. So I showed up with my punch cards with my program on them, and I went to the brand new academic center. It was new. And in the basement of the academic center was the computer center. And I went up to a desk and I gave them my cards and I said, I want this loaded on the mainframe so I can run it. And I got the old GW look. What? We don't do that. We run the financial records for the university. we let students come in occasionally and run programs if they're in a class. And I persevered, and eventually they loaded it up on the machine. But then I had another trick that I had to do. I had to find some place to punch cards. Now, this is not the GW Punch Card Center. It's way too well lit. The Punch Card Center was in the basement of Rice Hall, which was also a new building at the time. And they punched in all of the academic, financial records. And they let me punch cards during lunch break. And so I punched my data onto cards and then ran back over to the academic center and gave it to them, and they told me they'd run it at night and I could get my results. And I got my results the next morning, and I did what all the old computer geeks in here remember. You go up to the desk praying that it's going to be a thick stack of paper, which means it ran. If it's a thin stack of paper, you got an error code really close. And I ran it, and I was so excited. I got results. I went back to the lab. I did some more work. I went and repunched some new cards and went back to the academic center to hand it to them. And they said, "We already ran your program." we threw the box of cards away. And that was the GW way. You know what? It gave me the incentive in the early 80s to get out of punch cards and onto mainframes. And you all remember this. I had one in my office along with a computer terminal, and I had an account at the Smithsonian Institution, bless their hearts, to continue to run my data. And we went on from here to personal computers that could run data. But the data that we gather in biology always seems to be more complex than the computing power we have. Biology is an extremely complicated field. Things don't always work in a very rigid way, the way they do in chemistry and physics. Chemistry and physics, I don't know, I don't see any of the faculty in here, so I'll just say, that stuff's easy. You know, hydrogen always acts the same way. It doesn't matter if it's on Mars, or it's here, or it's 1 million years ago, or it's 1 million years from now. But mammals, 5 million years ago were different, and 5 million years from now they're going to be different. There's this historical contingency to biology that makes it really complicated. So we have very complicated data, very complicated things going on. And what I'd like to do is just tell you what some of the people who are just waiting for the switch to be flipped on this and what they're going to do, so you can get an idea of what some of the faculty members in the biology department are going to do with this computing center, just so you can imagine. Well, Dr. Kathy Forrester is not only the subject of a children's book, but the president of the Vertebrate Paleontology Society, an international society that looks at vertebrate fossils. And one of the things that she's doing now in collaboration with colleagues at the University of Texas is to take CAT scans of some of these fossils. She would really like to be able to analyze the CAT scan stacks, to be able to take fossils that have been crushed or moved in different ways and reconstruct them into whole organisms from her own lab at her own university. Then she would like to take things like this hadrosaur and let them run, model how they might have moved, how they might have functioned, and begin to do that sort of work. That's going to require more powerful computing than we currently have. Damien O'Halloran is jointly in the biology department and the Neurobiology Institute, and he studies neural circuits. Nerves never function alone. They function as groups, and they have their own feedback loops that go on within those groups, and he looks at olfaction. When you have these groups of nerves, if one fires, there's a cascade or network of how these interact with each other. Modeling this and simulating what goes on in these neural networks is going to let him work much more efficiently. Dr. Eleftherianos works on immunology, and he's got a very complicated system where he's looking at multiple parasites inside of one host. So he's looking at flies that have worms, and the worms have bacteria in them. And the immune responses that you get are extremely complicated. This is his graduate student explaining this to Nobel Prize laureate right there. The Smith Lab also does immunology, and she's looking at the complement system. When your body is challenged by an invader, what cells get released? How do they attack? Once those cells are in your body has to regulate them. Inflammation and immunocells in your body can do quite a bit of damage. So your body tightly regulates them. How does it regulate them? If this gets flipped on, does that get flipped off? Does that how? Yeah, it's very complex, and she would like to be able to model these systems. Scott Powell and Amy Zan both do very similar things. They look at the interface between organisms in a whole community. So how are the plants and the animals and the fungi all working together so that an ecosystem can function? Scott focuses primarily on ants, which are really cool. There are 11,000 species of ants. That's a lot. They have different castes. Some of them have different forms. There's worker ants and soldier ants, and they're all different forms. What makes a worker ant be a worker ant? How does wood get broken down with fungi? That's something that Amy Zan's working on. And then how does that contribute to the ecosystem functions that we all use? You depend on these things to happen in the ecosystem, or you wouldn't have clean water or clean air. It needs to be modeled in order to be studied effectively. Dr. Ormiga always tells me if it wasn't for spiders, we'd all be dead. Buried under a huge mountain of insects, because spiders are the #1 predators on the planet. They eat the insects. And just because they're little and you don't notice them doesn't mean it's not important. This is just a spider hand, a picture taken from the SEM. Dr. Ormiga has a joint grant with Gonzalo Garibay at Harvard to do whole genome analysis of spiders and to do next-gen sequencing. Well, this generates an awful lot of data that has to be analyzed. Gustavo does other things as well. He just came back from Robinson Crusoe Island, which is out here, give my hand not to shake, in the middle of the Pacific off the coast of Chile. Well, he didn't have to compute much to get there. He just needed National Geographic to fund him. But he's collected a lot of spiders, and he's working on a project using image recognition or face recognition to try and come up with quick ways of identifying arthropods. And some of these arthropods that he collected on this field trip are going to be put into this image recognition software. And then the baby in the department. This is Alex Pyron's lab. Alex is 24 years old, and he's been our faculty member for 2 years. He postdoced for 3 years at Stony Brook. Now you do the math as to when he finished his PhD. But Alex is looking at things backwards from Gustavo. What Alex is doing is he's interested in developing new theories and new methods of data analysis. And his real interest is in the theory. But to do that, he needs a test organism. So he studies lizards and snakes, and again, uses whole genome sequencing, and then models different aspects of biogeography and other things. And this is his undergraduate who works in his lab, and Kat Henley, who just won this past year the best graduate student teaching prize, all in this lab. So when you think about high performance computing and next generation sequencing and all of these things, you might not always think about all of these things like snakes and spiders and flies that have worms, that have bacteria in their guts. But all of these things are part of what we're going to be doing with this system. And it's all very exciting as far as I'm concerned. I can't wait to try out this machine, this equipment. I'm going to hope, and I'll ask Sean and Brian about this later. The first time I ever tried really high performance computing, not really high performance computing, real big data sets, we couldn't do it at the GW campus, but I had a colleague at the University of Stockholm who could. And so we used Gopher, there's another old term, to send packets of data to the University of Stockholm. And as I was doing that, I got a call from the head of the then IT office at GW, who said, I just got a call from my colleague in Stockholm. Whatever you're doing, stop it. Their computer has crashed. So with that, I'll turn it over to Keith and let him continue talking about how wonderful this is going to be.
I do know what non-professional IT support is. And that's me, right, trying to get my computer to work. And sometimes that works all right, and most of the time not. So it is nice that we do have professional IT support, because, man, can biologists use that. The beauty of this cluster is to have a centralized resource for research. And I thank Dean Barrett for the vision of putting this together, Sean Conley for the action of putting this together, David Steinour and Brian Ensor for providing housing and personnel to run this thing so I don't have to, right? Which is what has frankly been going on here at GW, is lots of little computer clusters and lots of little corners of lots of little labs with faculty who frankly have better things to do, trying to run their computing cluster and get their analysis done. Now we can free ourselves from doing that and get back to the science and teaching that we're actually supposed to be doing, and use this resource as a core facility is meant, which is analyze, push some buttons, put my data on it, let it analyze, and send me an email next week when it's done being analyzed, or at least when it's tired of analyzing my data. As Diana rightly pointed out, many of our problems in biology, frankly, are never done being analyzed, but there are times where we give up and take the best answer we can get at the moment. We have some examples of that. I'm the director of the Computational Biology Institute here on the Virginia campus. We are in the midst of hiring some faculty, and based on the 155 candidates that we're sifting through, we've got some excellent choices, and they'll bring some amazing expertise with them here at GW. We've got some research going on in our own lab that we have, and some posters down the hall on one on a new piece of software that the manuscript was just accepted in genome research for identifying pathogens. So this is basically to take a sample from whatever your sample is, whether you want to know what that bacteria is on that apple that you're going to eat, right? Or if you want to know what that was that somebody just sneezed on your shoulder, or if you have a urinary tract infection and you want to pee in the cup of one of your physicians and send that our way, we can do next-gen sequencing on that and then analyze it with this piece of software and identify the pathogens in that sample. That's a computationally difficult problem that we developed some software to analyze the data, but that software needs to run in a high-performance computing environment because we need some horsepower to run as Diana gave a nice example of back in even the old days, to actually get the data there in the first place. A lot of these data sets are gigabytes in size. One of the other projects we have is looking at bacterial genomes, looking at diversity of some bioterrorism bacteria, all the favorites, Yersinia pestis and things like that. These data came to me when I was at my former institution on a hard drive via FedEx, because that's how big the data are. and you need a big computer to analyze those kinds of data. So we are anxious to get on this computer. I was hoping that there'd be a basket being passed around with usernames and passwords, because about everybody I've talked to so far has said, how do we get on this thing? So we're anxious to get on this thing, and in the interest of anxious to get on with it and to it, I'm going to end so we can take a look at it and get our passwords. Who's passing out passwords?
Thank you.
Thank you all. It's obvious and clear that this is a piece of equipment and supporting staff that will serve the university very well. Thank you for being here. I would be not serving my field very well if I didn't challenge Diana on some of the comments she made about physicists. A whole bunch of them were, by the way, around you. They're just very low key. You can't see them. And those are the most dangerous types of enemies. I remember actually when we had punch cards, and as an undergraduate student, I had to go to the Stewart Hall, or the Bell Hall, where actually your department is now. That's where the computer center was. And for a long time, one reason you couldn't find any punching machines there was because they were trying to wean faculty and students like me off of those punching machines and put them on monitors. And they put those punching machines in the hottest and most undesirable places, like underneath the staircase, where you had to go and sit like this. One of my first experiences was a computer science class I took as a freshman. I did a nonlinear equation and plotted, because there's no plotters, so the equation was like a spiral. So I still have that. And a few years ago, I was running on the street, I saw Professor Meltzer, who was retiring from computer science, and I said, "You don't remember me, but this was one of the projects I had, and I still have the punch cards." And he looked at me funny, and he said, "You're a sick man." So if you're worried about the phlegm on your side because somebody spit on there, or bacteria or cup, you can go to a biologist. But if you're worried if you're going to be surviving on this planet, there is an event that's about to happen, well, give or take 100,000 years, a big gamma ray burst that's going to happen, that if the angle is right, will wipe out all life as we know it. So my friends here, this very quietly sitting out there, they could use this high-performance computing model, Professor Duga and Glenn McLaughlin. Nothing could be more complicated than modeling the interior of a star that's about to explode in those types of turbulent energies. Or my friends who are trying to find out the properties of a nucleon, knowing the interactions, quantum chromodynamic interactions between quarks, they will challenge all of you on that. But that's a different story. Today we're celebrating the equipment today. One other thing is, if you haven't figured this out, is we are enthusiastically encouraging all of you to come here and set up station for research and offering your educational programs here. So, so much so that in my enthusiasm to convince my physics colleagues to come here, they thought I had something to do with the problem with the Corcoran Hall, where the foundation was failing. And I assure you, that was the hand of God, not me. But thank you again, and Dave, thank you for your willingness to partner with anybody who's willing to pay you $1 million. I appreciate that kind of partnership. Thank you again, and there's a tour of the servers. Please, go for a visit and hang around, eat some more food. If you have any other questions, come and see me. But I would like, again, because my colleague Dean Barrett has decided to step down, and fortunately will be with us still as faculty at GW, I would like to really show our appreciation for all the great work she has done for the university.